Hello everyone, myself Manoj. I am pursuing my mechanical engineering degree from Madras Institute of Technology, Anna University. So I'll be discussing about short peening. So, so these are the contents which I'm going to discuss. Introduction to short peening, why and where short peening is used, how short peening works, factors affecting short peening methods. Introduction. Short peening is a cold working process in which the surface of the part is bombarded with small spherical media called shot. Each piece of shot striking the metal acts as a tiny peening hammer, imparting a small detention or dimple on the surfaces. Below the surface, the compressed grains try to restore the surface to its original shape, producing a hemisphere or cold worked metal highly stressed in compression. Overlapping dimples develop a unique layer of residual compressive stress. So, why we use short peening? The atoms of the surface of the manufactured metal will be mostly under tensile stresses left over from grinding, heat treatments, or machining. Cracks propagate easily in areas of tensile stress because the tensile stresses are already working to pull the atoms of the metal apart. By short peening the material, you introduce a layer of compressive stress by compacting the material. As the short peening is performed, the atoms on the surface of the metal become crowded and try to restore metal's original shape by pushing outward. So, where short peening is used? Short peening is used on gear parts, cams, camshafts, clutch springs, coil springs, connecting rods, crankshafts, gear wheels, leaf, suspension springs, rock drills, and turbine blade. So these are the various areas like where short peening is used. How short peening works? Short peening process impacts the metal surface with small petals, round metallic or glass, which is high enough for force to deform the surface plastically. A compressive layer is generated when the impact of all the particle shoots produce small detentions in the top of the surface layer. The layer beneath the top surface is then compressed, generating a compressively stressed layer underneath the short peened area. This layer helps to prevent the stressed area to crack as a crack cannot propagate in a compressive environment. Short peening methods. First, mechanical short peening. Conventional short peening is done by two methods. One involves accelerating short material with compressed air. Short is introduced into a high velocity air stream that involves accelerating the short with a wheel. The short gets dropped onto the middle of the wheel and accelerates to the outer edge where it leaves on a longitudinal path. Next is dual short peening. Dual peening further enhances the fatigue performance from a single short peen operation or by repeening the same surface a second time with smaller shot and lower intensity. Laser shock peening. Laser shock peening utilizes shock waves to induce residual compressive stresses. Next, strain peening. Dual peening increases the compressive stress on the outer surface of the compressive layer. Strain peening uh, develops a greater amount of compressive stress throughout the layer. Factors affecting short peening. Peening exposure time. The saturation curve is generated by exposing the aluminum strip to the short spring for varying amounts of time when arc height is plotted against time. The first point on the curve for which doubling the peening time increases the arc by 10%. Next, shot size type. These physical and mechanical properties of shot determine the quality of impact on the surface. If the shot is softer than the surface it is intended to compress, then the shot will be deformed and fully intended peening effect will not be achieved. Then the method is careful to prevent shot fracture in the conditioning stage. Other factors such as roundness, broken or fractured particles, and miscellaneous contamination. The depth of the deformed layer decreases with increasing hardness of the material treated. Peening intensity increases as the shot size increased. Next, impact angle. The angle of impact of the shot with the target should be as close to normal, that is 90, which attention paid to effect of rebounding shot interfering with the uh, impinging shot. Below 45 degree is considered to be practice for surface treatment for two reasons. First, the energy imparted is less than optimum and will not impart a deep compressive layer. Last is shot velocity. The velocity of the shot as it impacts the surface is largely determined by three factors: nozzle size, air pressure, and distance to the workpiece. So this is all about shot peening. Thank you.